So this is quiz 2 in the conic section. First quiz was circles and ellipses. This next quiz is on hyperbolas and parabolas. So you can go back to 4.6. So this quiz goes from 4.6 to 4.10, which is this current review. Okay. So as always, know the standard forms of the equations. Okay. Given the standard form, can you graph a hyperbola or a parabola? Know how to find all the elements. You know, hyperbola has a center, a focus, transverse axis, conjugate axis, focal length, vertices, foci, and then look at elements of a parabola, a vertex, axis of symmetry, focus, directrix. You know that parabolas will either open up or down or left or right. They come in two different forms. Completing the square. We did that with circles and ellipses. We continue to do that with parabolas and hyperbolas. Give the equation of a hyperbola. If I give you the graph, give the equation of a hyperbola. If I give you the center, the vertices and endpoints or lengths of the conjugate axis. If I give you a center, a focus and endpoints of the conjugate axis. Or if I give you an equation of hyperbola, given the focus, give me the equation if I give you the foci or the vertices. Same thing with parabolas. Give the equation of parabola by looking at its graph. Give the equation of a parabola if I give you the vertex and the focus or the directrix. Give the equation if I give you the directrix and the focus. Okay, so each of those elements, and you should be able to come back with the equation. So let's jump into the problems. Graphing a hyperbola. And the instructions: graph the hyperbola, the center, the vertices, the foci, and the asymptotes. When I look at this, the center is going to be at -2, 2. To find the vertices, I did not ask you, but you'll need somewhere in your paper to write. A is equal to 2. B is equal to 4. So if I graph the center at -2, 2, okay, that is my center. I know at this point, when I look at this, that this is going to be a horizontal hyperbola because I see a positive sign with the x term. So the vertices are going to be on the vertical line that goes through that center. So if I look at it, if A is 2, then the vertices are going to be 2 units on either side of the center, left and right. So it looks like that those are going to be at 0, 2. That's 2 to the right. If I go 2 to the left, that is going to be at -4, 2. Okay, so I have a center, I have a vertex and a vertex. Okay, and now let's look at B. B is 4. So if I go up 4 units, 1, 2, 3, 4 right here, and then down 4, 1, 2, 3, 4, then I can just make a box right here. That lets me draw the asymptotes. And that last one didn't quite hit right. There we go. So that lets me draw the asymptotes. I know that the graph, since it's a horizontal hyperbola, it looks like this. Only thing left to find would be the focus points of their foci. So I know that c squared equal a squared plus b squared. So c squared in this case is equal to 20. So c is equal to the square root of 20, which is just 2 times the square root of 5. So that means that I'm going to have the focal points at a distance of 2 square root of 5 away from the center. So the foci are going to be at -2 plus 2 root 5, 2, and -2 minus 2 root 5. That's that focal length, 2. Okay, so 2 root 5, let's estimate what that is. So 2 times the square root of 5 is, let me get an estimation of that, about 4.5. Okay, so on my graph then, so 4.5 minus 2 is going to be about 2.5. So somewhere right here is a focal point. And then if I go another 4.5 and the other direction, somewhere right here, is the other focal point, okay? And the equation of the asymptotes. This one's pretty easy. Just look at here. Y minus 2 equal plus or minus B over A. So that's 4 over 2. And then look right here, and it's x plus 2. Okay? So y minus 2 equal plus or minus b over a, x minus h, and there we go. Let's look at the next one. Problem number 2 is a parabola. So you recognize here that the y is the squared term. So that means for every x, I'm going to have 2 y's. So this parabola either looks like this, or it looks like this. Okay, it is a horizontal parabola, either opening to the left or opening to the right. Okay, so the vertex is going to be at 2, 4. So 1, 2, and 4 is right here. Axis of symmetry. This is a horizontal parabola. So the axis of symmetry is going to run through that vertex. This is my axis of symmetry right here. This is one of those where just doing it on a graph is going to help you. That is the line y equal 4. Now, so there's the center, the focus. Okay, to define the focus, I need to figure out, okay, the form of this parabola is x minus h equal 1 over 4p, y minus k squared. So I need to figure out if 1 over 4p equals negative 1 over 8. That means that p is equal to negative 2. Okay, so this parabola I know is going to open to the left. So the focus, so if this is my center, then the focus is going to be 2 units to the left, and the directrix is going to be 2 units to the right. So this parabola looks like this. So the focus is 0, 4, and the directrix is the line x equal 4. Number 3, graphing a hyperbola again. This is a vertical hyperbola. So I can tell that the center is going to be at 3, negative 2. So at 3, negative 2. I know the vertices. Okay, so if this is vertical, the vertices are going to be on a vertical line going through here. I know that A is equal to 3, B is equal to 4. So the vertices are going to be vertical up a distance of 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so the vertices are going to be at 3, 2, and at 3, negative 6. And the focal length, c squared, is equal to a squared plus b squared. C squared is equal to 25, so c is equal to 5. So to find those foci, it's going to be 5 away from this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So those 2 points for the foci are at 3, 3, and 3, negative 7. And I know enough to graph this guy now. So remember, A is equal to 3. So 1, 2, 3 right here. 1, 2, 3. So I can draw a box. The asymptotes are this way. This is a vertical hyperbola, so it goes this way. So here's my center, vertex, vertex, focus, focus. And the equation of the asymptotes is y plus 2 equal plus or minus b over a, x minus h. Next one is a parabola. the x squared is the x is the squared term. So for every y, I have two x's. That will look like this or like this, one or the others. I see a positive sign in front, so it's going to have to look like this. So that means there'll be a focus up here and a directrix below it. Okay, so the vertex. So the vertex of this parabola is going to be -2, 0. Okay. The axis of symmetry. This is a vertical parabola. The axis of symmetry is that line that you see right there. X equal -2. To find the focus, the equation, this is the form y minus k equal 1 over 4p x minus h squared. So if 1 over 4p equal 1 over 16, that means that p is equal to 4. So from this vertex, I know this parabola is opening upward. If I go up 4, 1, 2, 3, 4, that is a focus. Go down 4, 1, 2, 3, 4, that is the directrix. Okay, and so you can graph this parabola as such. So the focus is at the point -2, 4. The directrix is the line y equals -4. Give the equation of the hyperbola in standard form. This is completing the square. So factor out of 4, x squared minus 6x, leave some space, minus 9, y squared plus 4y, leave some space, equals 36. Okay. Double checking to make sure so you can multiply this out. 4 times x squared is 4x squared. 4 times -6x, -24x. -9 times y squared, -9y squared. -9 times 4y, -36y. Now we complete the square. I have to add 3 squared and 2 squared. Okay, so ask yourself what you really did on the left side of the equation. So this is 9, so it looks like I added 36. And in the next one, this is 4. It looks like I subtracted 36. Okay, so I do that to both sides of the equations. I end up with 4 x minus 3 squared minus 9 y plus 2 squared equal 36. For standard form, this needs to be equal to 1. Let's divide everything by 36. And you get x minus 3 squared over 9 minus y plus 2 squared over 4 equal 1. Okay, that's the hyperbola in standard form. The next one is the parabola. Okay, I only see a y squared, so that means I am after it looking like this: x minus h equal and 1 over 4p y minus k squared. That's the form that I'm after. So let's move everything let's keep the y's on the right side. So I'm going to have x minus 13 equal 3, y squared plus 4y. And now I need to complete the square in y. So I need to add 2 squared, that's 4. So I'm adding 3 times 4, I'm adding 12 to the right side, which means I must add 12 to the left side. So this is x minus 1 equal 3, y plus 2 squared. And that's it. So this is now in standard conic form for a parabola. X minus 1 equal 3, y plus 2 squared. Look at the graph and come back with the equation of the hyperbola. This is a horizontal hyperbola. So if I look at this, it may be helpful just to draw this box that goes here. So we go up here, go across to the line, down to the line, back and up. When I look at this, I can see that the center is at -2, 1. So the center is -2, 1. When I look at this, I can see that A is equal to 2 and B is equal to 3. Since it's horizontal, the x term comes first with a positive. So x plus 2 squared over a squared, which is 4, minus y minus 1 squared over b squared equal 1. Find the equation of this parabola. So this parabola is going to have a y squared term. For every x, there are 2 y's. So this is of the form x minus h equal 1 over 4p y minus k squared. So if I look at it, the vertex is right here. The vertex is negative 4, 2. So I've got a vertex negative 4 and 2. And p, remember, p is going to be the distance. P is the distance from here to here and from here to here. So 1, 2, 3. So this is 3 and this is 3. Now I can see that p is negative here because this opens to the left. So p is equal to negative 3. And that is all I need. So this is x minus 2 equal 1 over 4 times negative 3 times y. Sorry, let me back up. The vertex is negative 4, 2. So this is x plus 4 equal 1 over 4 times negative 3 y minus 2 squared. So this is x plus 4 equal minus 1/12 y minus 2 squared. So that's the equation of the parabola in standard conic form. Now I give you scenarios, I give you a scratch graph, so I'm not grading the graph, and use that information to come up with the equation. Give the equation of the hyperbola that is centered at 4, 3. So this is 4, 3. And it has a vertex at 4, 5. So that's a center. That's a vertex. Okay, I immediately know that this is a horizontal hyperbola. So if I've got the center and the vertex, that's what I have. So I know that the center is 4, 3. And that vertex tells me that A is equal to 1. Okay. And let's figure out, it has a conjugate axis of length 6. So the conjugate axis goes up 3 and down 3. That's how it has a length of 6. What it means to me is that B is equal to 3. So since this is horizontal, my x term comes first. X minus 4 squared divided by a squared minus y minus 3 squared over b squared equal 1. Okay. Give the equation of a parabola with a vertex of 4, 4 and a directrix at x equals 6. Vertex of 4, 4, that's right here. The directrix is the line x equals 6. So I know if that's a vertex and a directrix, I know this parabola has no choice but to open this way. And I know that the distance from here to here is 2. Okay, since it opens to the left, it's negative, so p is going to be negative, so p is negative 2. And the vertex is 4, 4. So the form that I'm after is x minus h equal 1 over 4p y minus k squared. So this is x minus 4 equal 1 over 4 times negative 2 times y minus 4 squared. One final simplification, x minus 4 equal negative 1/8 y minus 4 squared. Next, give the equation of a hyperbola, and they give us the center, a vertex, and a focus. So it's centered at 2, 1. So I'm going to need the center at 2, 1. So 2, 1. It has a vertex at 5, 1 and a focus at 7, 1. Okay, so I've got the center, the vertex, and a focus. I know that this is a horizontal hyperbola at this point. Okay, so the distance from the center to the vertex, 1, 2, 3. I know that A is equal to 3. From the center to the focus, 1, 2, 3, 4, 5. I know that C is equal to 5. So that means that A squared plus B squared equals C squared. So B squared is going to be C squared minus A squared. So B squared is going to be 25 minus 9. B squared equals 16. B is equal to 4. So if I know A, B, and the center, and I know that it's horizontal, no other choice. This is x minus 2 squared over A squared minus y minus 1 squared over B squared equal 1. Give the equation of a parabola with a vertex and a focus. So the vertex is at 2, 2, okay, and the focus is at 2, negative 1. Focus is at 2, negative 1. So I've got a vertex and a focus. So that's 1, 2, 3, 1, 2, 3. Somewhere up here I have a directrix. No choice but this parabola to open downward, okay? So in this case, I know P is negative. So P is going to be negative 3. And the form for this equation is y minus k equal 1 over 4p x minus h squared. So this is y minus 2 equal 1 over 4 times negative 3 x minus 2 squared. So y minus 2 equals negative 1/12 x minus 2 squared. And that is it.